Drum roll. This is the last video of the semester. Woohoo! So we had just finished C in the last video. We divided by a negative. So remember, anytime you divide by a negative, that means you flip the inequality. X is less than -2 gets a parenthesis because there is no equal sign. Less than shades left, and then when we go do the interval notation, we have to keep it in the same order. So it's -infinity, comma, -2, both with parentheses, because infinities always have parentheses, and this is a parenthesis because there's no equal. We can't equal 0. So, I can't just walk away from B, even though I said I was going to. I'll just explain it here a little bit. So it's a special case. We've learned and talked about this a ton during the class. When you square a number, it's positive. Always. -2 times -2, +4. +2 times +2, +4. So if you take a positive number plus 1, isn't that always going to be greater than 0? So a positive number plus 1, or this could even be 0. 0 squared is 0 plus 1. It's still going to be greater than 0. So since this is always greater than 0, because there's no way to make it less than 0 with the real number system, because everything squared is positive. So since it's always greater, boom, we can put any x in we want, because nothing will make it equal to 0 or less than 0. And those are the two things that we can't have. We can't have a negative in there, and we can't have 0. And there's no way to make that 0 or a negative no matter what you plug in. Unless, of course, it's a imaginary number, but we are not working with imaginaries. Okay, last page. So logarithms are used in a lot of different things in the real world. Decibels, like if I was going to measure the decibels of a concert, I use logarithms. If I'm going to measure the pH of something in chemistry, I use logarithms. If I am going to, let's see, what else uses it? Carbon dating, I think. I don't know. You'll see all different applications of it in the next class, but it is a naturally occurring thing in the world. So it is used a lot for, things in science. Radioactive decay, I believe, is an exponential. But anyway, you'll see a lot of different applications of log. So in this chemistry, the pH of a solution is given by the opposite of log of the hydrogen ion concentration. I know that sounds like crazy business, but guess what? These are all calculator problems. You plug the number in, type it into your calculator. So H plus is the hydrogen ion concentration. And distilled water is a base, so it's approximately 7. A solution under 7 is acidic or an acid, and a pH over 7 is a base. So that just kind of gives you a little background on pH. So distilled water is supposed to be like the neutral, like the base. And then under that, acid. And then over that, oh, I got something all over. And over that is a base. Okay. So this is almost neutral. So the gastric juices in your stomach have a hydrogen ion concentration of 10 to the -1, and this is just, it's read moles per liter. Doesn't apply to the problem, but that is the correct label. Find the pH of your gastric juices. Well, we're going to take this formula. pH equals the opposite of the log of the hydrogen ion concentration. And they gave us the hydrogen ion concentration. So we are going to plug it in. So opposite of log of, put that in place. So it'd be 10 to the negative 1. So we could use a calculator, but guess what? This one can be done without a calculator. Remember, if there's no base, it's 10. So when the base of the log and the base of the exponent are the same, the answer is the exponent. So this is really negative, and then the answer is negative 1. So what's the opposite of negative 1? pH is 1. And pH doesn't get a label, so you just say 1. So that negative came from here. Our first page of this lesson told us that when the base of the log is 10 and the base of when the base of the log and the base of the exponent are the same, the answer is just the exponent. So look on page 12, the very first page of 8.4, if you forget that. And remember, anytime there's no base present, we can assume it's 10. So that came to be negative 1. This negative comes down, so the opposite of negative 1, positive 1. So that would be another type of question that your 150 teacher would put on the no calculator test. Because they'd be like, oh, well, you should know how to do that. If you were using a calculator, you type it in basically just like you see it. You type the negative sign, then you type the log. It opens a parenthesis for you, and you do 10 caret negative 1, close your parenthesis, boom, just verified our answer. But this is a really important property of logs, so remember that inverse property that I told you about earlier today. When the base of the log and the base of the exponent are the same, the answer is the exponent, but then we had that negative in front of it, so the opposite of negative 1 became positive 1. Okay. Easy stuff. And pH doesn't get a label, so you just say pH equals. So let's do one more, and then you guys can try one on your own. So, tomato juice. So we just learned that your gastric juices are very acidic, right? 1. So anything under 7 is acidic, and these are 1. So that's why people get ulcers, because that acid eats through their stomach. So what do you think tomato juice is going to be? I'm guessing acid. I can't remember exactly from semesters past, but it seems like it should be acidic. I don't know. It soaks up people's alcohol the next day, so what would that make it? Okay, so pH equals the opposite of the log of the hydrogen ion concentration. Tomato juice has a hydrogen ion concentration of 10 to the negative 4.1. So we're going to put that in there. Moles per liter. Find the pH. So negative log 10 to the negative 4.1. Can we do the inverse property of logs again? Absolutely. Base is missing. So the pH is going to be bring down this negative and then evaluate this. When the bases are the same, the base of the log is the same as the base of the exponent. The answer is the exponent. So bring down negative 4.1. So the opposite of negative 4.1 would be pH of positive 4.1. So yes, tomato juice is acidic. Not as acidic as your stomach juices, but acidic. So anything under 7 is acidic. Now, I remember when I was young, my mom used to drink milk because she had an ulcer. So an ulcer is caused by acid. So my guess is milk is going to be pretty close to distilled water, or maybe it's going to be a base. But I don't think it should be too acidic, because I do remember I don't know, maybe people still do it when they have a ulcer, drink milk to help it. I don't know what it does. Neutralize it, I guess. Neutralize the acids in your stomach so they don't create sores on your lining. Okay, let's do our last problem of Math 121. So we'll do milk is 3 times 10 to the negative 7 moles per liter. So that's its hydrogen ion concentration. So pH equals negative log of the hydrogen ion concentration. So pH of milk is going to be negative log in place of the hydrogen ion, right? 3 times 10 to the negative 7. So now we can't use the base formula because there's that 3 in front. Now, if the 3 wasn't there, yes, then we could. But that 3's in front, so we're actually going to have to type it in the calculator. So pH equals, okay, so we have a negative, we have a log, parentheses are already open, so 3 times 10 caret negative 7. Close your argument. Boom, look at that. Almost right in the middle. So that was our guess, that it was going to be close to 7. I thought maybe it might be a little higher, actually. So round to the nearest tenth, the direction says. So the pH of milk is approximately, tenths is the first decimal place, 6.5. Almost neutral, close to a base. Okay, that is it. So now it's up to you guys. So make sure you work on those 4 sections in chapter 8, because I put about 2 or 3 questions from each section on the final. And remember, the best way to get ready for your final is doing your Connect Math final exam review. All I did was make it a test. So your review is your test. It will just give you different numbers. So make sure you know how to do every single one of those questions on Connect Math final exam review. Email me, send me pictures, log into the tutors, whatever you need to do, but make sure you know how to do every one of those problems. I believe there's 40 problems. Our final exam is a 2-hour period, so you'll have 2 hours to do 40 problems. But if you work on the review and do 1 or 2, and remember, once you do 1 on the review, you can hit try another example, and it doesn't affect your score, but it gives you another one to practice on, because sometimes 1's not enough. So study hard, and I'll see you guys next week for final exams. 9 a.m. class takes their final exam on Monday at 9 a.m. The 10 a.m. Math 121 class takes their final on Wednesday at 10 a.m. See you guys. Let me know if you have any questions.